Hello everyone, good afternoon. My name is Lukáš Czerner and I prepared my presentation for Qubes OS today. I prepared this exact topic just because I really love the system. I used it for about 5 years. Unfortunately, I don't get to use it as much anymore, but my hope is that by presenting this to you, you'll be able to at least try it out, and some of you might even like it as well. So what it is, the Qubes OS is a security-focused operating system that uses virtualization to isolate different tasks and applications in separate VMs. Here, I just want to mention that sometimes I'm going to use the term VM, sometimes I'm going to use the term cubes or cube, and that's because Qubes OS uses this term and it means VM, basically. So don't get confused, VM equals cube. So the system allows you to separate different parts of your digital life, like for example banking or general browsing or working on a project, to different parts of the VMs. And this is in order to limit potential damage from any potential security breaches. As you can see here, even Edward Snowden endorsed the system as the best operating system available today. I think that the guy has some credit because of what he's doing. He needs some security in his life, I think. Before we start, let's just say a few words about me. I am a software engineer. I've been doing programming for over 25 years now. I've got some contributions to open source projects, Linux kernel, and some core user space utilities. I've worked as a maintainer of ext4, JBD2, and some corresponding user space utilities in Red Hat. And currently, I'm employed by Czech MOD, where I'm focusing mostly on cybersecurity and cognitive security. Now, let's dive into the architecture review of Qubes OS. Qubes OS is built on the Xen hypervisor. I'm sure many of you have heard it. I'm not going to say what it is. And it provides the foundation for the hardware isolation and virtualization. It uses 3 main types of VMs. That is DOM0, for those of you who understand what Xen is, already know what it is. Then some service cubes, and then app VMs. I'm going to explain that, what it means. The core of the system is the administrative domain that is called DOM0. And that's the privileged domain. That's the domain that can do anything within the system. It is acting as a gatekeeper for the rest of the system. It's managing the VMs, running it, stopping it, managing it. It runs the window manager as well, which in this case for the default installation is XFCE, so it's quite usable. And it also assures the communication between the cubes. So it acts as an intermediary between the VMs and assures the communication flows can be established between those. And we'll be talking about that a little bit later. However, it's not meant to be used as your general computer, the DOM0, I mean. You're not going to be using it for browsing the internet. It actively is trying to prevent you from doing that, and that is because the DOM0 is the most crucial, important part of the system, and it needs to remain secure. So it doesn't even have networking access. The other part is service cubes, and the service cubes are specialized cubes that handle stuff like networking connection. It handles firewalls. It owns all the USB devices and manages other functions and provides services for the other cubes. So for example, in terms of networking, it owns the physical network interfaces, and it will provide network for the other VMs or other cubes. And on top of that, it's app VMs, which is the place where you run your isolated applications, like you can imagine like a web browser or whatever you do on your system. And those are based on Linux distributions, or you can run even Windows in it. But by default, there is I think in Qubes OS, by default, you get Fedora and Debian. You can choose between those, and you can run your applications within that. Now, the isolation. How is it done? As I said, it's based on Zen. Zen is the hypervisor that everything runs on. And so the virtualization provides each cube with its own virtual CPU, memory, disk, network interfaces, and so on. There is also, obviously, hardware-enforced memory isolation to prevent other VMs from accessing each other's memory, obviously. There's device isolation with some hardware-enforced functions that protects against compromised hardware being able to access the memory of other cube and so on. But it also isolates these hardware devices into different cubes. As I said, for example, the networking cube can own the networking interfaces, the physical networking interfaces, so that no other cube owns it, but it will own it and provide network for the other cubes. The same applies to USB devices. You can have many USB devices, and all the USB hubs within your machine will be assigned to this particular VM, and this particular VM will reassign the USB devices as you wish to the other cubes. So you're in control of that. There's also GUI isolation, which works by using each VM's X server, and that uses specialized driver that paints the graphics into a frame buffer, which is located at a specific memory location within RAM, and that location is actually set up by DOM0 itself. So it doesn't use real hardware, it just writes into a memory, into RAM, and where is it taken by DOM0. And it is also set up by DOM0, which means that app VMs and the windows that is actually drawing have no idea what other windows are in the system. They don't see anything else other than their own frame buffer. There's also clipboard isolation. That's one of the problems I've noticed with new people trying to use the cubes, like doing clipboards and copying stuff over from one VM to the other. It is possible, but there's a two-step copy-paste process to prevent silent data theft, right? So you have to intentionally copy stuff into the clipboard within the VM, and then intentionally copy it from the VM itself into DOM0. And then if you want to pass it somewhere, you have to intentionally pass it into the window in the other VM, and then pass it into wherever you want it to pass within that VM. As I mentioned, all communication between VMs is mediated by DOM0, and it happens through DOM0, and it's using something called vchan, which is a function within the Zen hypervisor. Can't work. Okay. Now about the inter-qube communication. Qubes provide a secure way for virtual machines, cubes, to communicate through this framework that is called QRexec. And again, this one is based on the Zen vchan technology. Zen vchan is basically just a bidirectional communication interface between different domains within the Zen system. The QRexec allows for mediated communication between the cubes, and the DOM0, as I said, acts as a mediator, intermediary. This is the one that all the information comes through. And so how it works is that, for example, there's a neat feature within the cubes that, let's say you're working in your work domain, you're doing some work, and you get a PDF, and you don't necessarily trust this PDF, you want to open it in disposable VM. You don't want to open it in your work VM. So there's a button, you click the button, open in disposable VM. What it does is it'll instruct the QRexec to initiate the request. The initiation works the way that it'll notify the DOM0 that there's this request. The DOM0 evaluates the request against its security policies that are user-defined. By default, in this case, it's going to be automatically accepted because you're doing something is going into disposable VM, so there is no security risk, but certainly you can change that. But in other cases, it can be either automatically allowed, automatically disallowed, or even user can be asked on every case. And after it's evaluated, if approved, then DOM0 launches a disposable cube, copies the files into it securely, and opens the PDF. Now, the same mechanism can be used for copying files between the cubes. So you can, again, with click of a button within the file manager, copy some files from one cube to another. And then again, it's QR exec that is asking DOM0, and DOM0 initiates the cooperation, initiates the information flow and the data flow between the two cubes. Virtual networking architecture. Qubes implements very flexible networking model. It ensures isolation and while obviously maintaining connectivity because you want connectivity within your cubes. As I said in the beginning, the app VMs don't have a physical networking device, but it has a virtual NIC, which it uses, and it relies on the service cubes to provide networks. Each app VM is on its own virtual LAN as well. By default, any communication between the cubes within the system is disallowed, but you can certainly change that as well. Then the other part is sysfirewall, which acts as regular firewall, and it controls which cube can access what resources within the network. And it's also, again, configurable by the user. You can disallow it completely. You can allow just certain hosts to be connected to, and so on. Sysnet, this is the one that owns the physical interfaces. This is the cube that actually has all the physical interfaces connected to it, and it provides networking to the other cubes. So in this picture here, the Sysnet provides network to sysfirewall, and sysfirewall provides network to the app VM. Right? So there's a chain. The system is very flexible, and you can set up all sorts of weird stuff. The most common is you can take a new cube, new service cube, you can create one, install your favorite VPN, and just plug in here, right? And so sysfirewall goes to the, provides network for the VPN cube, and the VPN cube provides the network for the app VM cube. And then when you run the app VM, all the traffic goes through the VPN itself. So everything is encrypted. The app VM doesn't have to even know what it's doing, and it has VPN protection. But that's not all. And there's also by default in Qubes there is a Tor Unix gateway, and you can plug Tor Unix gateway here. So immediately you go through Tor, and you don't even have to try. But that's not all. You can chain this stuff. So you can set up multiple VPNs, and you can chain them for some reason if that's what you want to do. Or you can set up multiple VPNs and have one for your work, one for your personal stuff, one for your something else, one for your browsing and whatever. You can have multiple VPNs and just channel the traffic from different VMs through those VPNs. Just very, very, very nice, very neat indeed. Now storage architecture. This one is a little bit complicated within the Qubes OS. I'll try to explain it as simply as I can so that you can understand it well. I hope I won't fail. I will try certainly. So in Qubes OS, the storage is, first of all, encrypted. The disks that you get, they are encrypted using DMcrypt. And on top of that, it is using LVM thin provisioning for efficiency of VM volume management. And then there is a very important part here I haven't mentioned yet, and this is templates. Templates in Qubes OS are special virtual machines which actually contains the whole operating system, like, for example, Fedora, Debian, Kali Linux, whatever, right? And instead of each app having its own full operating system copy, they inherit the root image from the template itself. This allows the app VMs to share the same base for efficiency and for other purposes as well. For example, if you want to update the system, then the only thing that actually updates is the template itself. Template updates, and then next time the app VM runs again, or reboots, it'll pick up the new version of the template and just run that. You don't have to update the app VMs as well. So you can have hundreds of them, and it's updated just by the virtue of updating the template VM. The app VMs themselves, they use snapshot-based read-only root images from templates, as I said. And so any changes to the system, to the root image, while you're running the app VM, go to the copy and write volatile overlay that vanishes after the shutdown. Only the home persists. So there's a home persistence as well. But everything that any change that you make into the root file system of the app VM will vanish, and it will, next time when you boot it up, it will take the fresh copy or fresh snapshot from the template. Again, it's a security feature, so you know that every time you boot it up, you have the original image of the template. Nothing goes into there. All storage operations are a little bit complicated when you see how it works in details, but it works automatically and seamlessly within the Qubes OS. From over the years, as I was using the Qubes OS, I've never had a problem with it. In fact, it actually saved my data multiple times, because what it does also is there are automatic volume revisions, is basically snapshotting, that happen just transparently every time you shut down your app VM. And it keeps a couple of snapshots back. You can certainly configure that, but I think by default it's 2. And so you have revisions of 2. You can increase that if you want. But that happens automatically. You don't have to set it up. You don't have to do anything. It's just there, which is very convenient. And finally, there's an app VM volume layout. There are several drives or volumes that it uses. The first one, XVDA, the root, as I said already, is a snapshot of a template root plus the volatile overlay that is going to be thrown away after the system shuts down, or not the system, but the app VM itself. Then there's a persistent private volume, so you still have a place when you can store your data. This is mounted at home, and some other locations as well. It's /RW, but it's a detail. There's a volatile image for swap, and there's a read-only image for Canyon modules and stuff like this. This system allows for flexibility and easy cloning of the VMs, which is nice. You can very easily clone the VMs, and we can very easily clone even the templates if you, for example, for any reason want to create a new template and base your other VMs on top of that, because just, let's say you want to install some new software that you don't necessarily need to have all the other VMs, just this one. So you create a new template and based on all your new app VMs on this template. There is an option for Btrfs-backed storage pool, but there's an option. It's not the default. I don't think it works very well. And the last thing I've seen is that it's slow. There are some performance issues with that, so they don't use it. I don't even know if it's on the roadmap to use Btrfs instead of LVM. Now, here I try to highlight some of the real-world use cases for which Qubes OS can be beneficial. Obviously, most of you are here are developers, so you can use Qubes, and I did that for several years. You can separate your coding environment and doing research and test in your disposable VMs and whatever. And the good thing is that you can also store your secrets in like secured vault VMs, which are set up so they don't have any internet access and so on. For security professionals, again, you can analyze malware in disposable VMs. You can do all sorts of stuff. You can set up your own virtual lab environment and things like that. You can use split GPG, which is a system that you can use GPG without having it without having your private keys in your cube. It'll be stored within the secure vault cube, and there's a system that can communicate with it. You can imagine it as a YubiKey or something like that, but virtually in the system. For journalists, right, you can help protect sources with dedicated communication cubes. You can use Tor and Unix and I guess, maintain like offline Qube for reading sensitive documents, which might be useful. And finally, for everyday users, I think that's useful as well. I mean, you can, as I said in the beginning, compartmentalize your life, your digital life. You can use your stuff for browsing. You can use OneQube for your services, for your email, other for banking, and so on. It's very flexible. You can do whatever you want with it. Now, this guy has a weird look. It reminds me exactly of my colleague when I showed him Qubes OS, and he was trying for a day to install VPN in it. This is exactly how it looked like. So it's not easy, right? It has some challenges to it. It has some learning curve, right? You have to do some mental adjustment. It introduces a number of new concepts and approaches that you need to learn and adapt to. And that's even if you're familiar with Linux. For someone who's not even familiar with Linux, it's a nightmare. You're going to look like this. Now, for basic use, Qubes OS is quite useful, I think. It's XFCE, so it's decently nice. It's well established, I think, already. But if you want to do something more complicated, you really want to know what you're doing. And that is because it's not very difficult to break the security model by doing the wrong thing in the wrong VM. It's actually very easy. It allows you to do anything. And so if you're doing that, you're breaking the security model, and you no longer have the benefit of even using Qubes OS. So, that's something to consider as well. There are also some hardware requirements. It doesn't work very nicely with some hardware. I think that they have a list of supported hardware on their website, and they have some guidance there as well. And you'll definitely notice the performance impact. It's not, if you're doing like easy stuff, normal browsing and stuff like that, it's not that difficult. But once you start doing some more challenging things, and especially multimedia and some graphically challenging programs, then you'll definitely notice the problems there. Now, it is secure, reasonably secure, but it's not bulletproof. It's still software, and software breaks and has bugs, of course. And I already mentioned that DOM0 and templates are two pieces where the security is the most important. Once you have DOM0 broken, then entire system goes out, right? There is no security at that point. The same goes for templates. If you have something wrong, something malicious in your template, then it propagates to every app VM that is based on this template. So template is something you need to be careful when you're setting it up. Now, just to recap, Qubes OS uses virtualization to isolate tasks and applications, provide security through isolation. It has unique architecture with template-based app VM, service cubes, and privileged DOM from managing everything. But it does require some learning and understanding and adaptation in order to be using it well. And of course, you can break it if you do the wrong thing. So this is definitely something to consider. But if you have hardware that supports it, I very much encourage you to try it out. I think that you'll like it, especially if you like to tinker with stuff and try things out. It's definitely a very nice thing to do. There is a learning curve, so don't give it up after a week of trying. But from my experience, what I can tell you is that once you stop using it, it's even worse, because you really want to go back and get all the goodies and all the good functions that it provides, and you actually miss it a lot. And finally, Qubes is open source, so you know what that means. It means that you can help develop it even further. So, thank you very much. If you have any questions, I'll try to answer it.
Yeah,
sure.
Do you think it would be beneficial for users to give them just an option to replace the whole storage stack with just Btrfs subvolumes?
So the question is whether it would be beneficial for the users to replace the whole storage stack with Btrfs subvolumes, right? I don't see why. I mean, it works well, and I've never needed to tinker with LVM there. Never seen any issues. And it's not something that a regular user of the machine will get your hands on, right? You don't see that. It just happens automatically in the background. You don't see that at all.
I asked this question because, as far as I understand, the team
Right.
And butterflies alone, they support compression.
Yeah. If that's important for you, then I guess it would be nice. But there's no options like that. It can be done. I've seen people doing this, just running butterflies. But there is no like easy GUI option that you can enable or disable, and it'll just work. It doesn't work like that, unfortunately. Any other question?
So if I do not learn as a security analyst, obviously, the benefits are there. If I want to use this as a daily driver, what's in it for me? Why would I want to use it instead of a distro solely based on app container? Sure, you can jailbreak out of the container and you breach the system. Same way, here, if you take a malicious flash drive, plug it in, then you infect .0, done.
Oh, no, you don't in fact know 0.
So who's taking care of the
USB?
hardware?
So as I said, the USB is managed by a separate VM, right? So it's passed through to this VM, and this VM is handling all the USBs. And so if you have a malicious USB, plug it in. Don't know what it does, right? But it maybe takes down the USB cube. But once it comes up again, it's disposable, so it's still the old syscube.
Okay, so bad example.
Right. And there's many small things like that, yeah, you might not think about. But for example, for me, many times I wanted to open a website that I shouldn't, right? Or open a PDF that I'm not really necessarily trusting. Of course, there are options, even if you're not using this. But
A full-fledged VM for that, like with a kernel.
right, that's what it is. Yeah.
Yes, but for a PDF, you don't need that kind of like overlay, so you can do it with a container.
Oh yeah. You can.
So the virtualized thing, as I understand it, it's useful in server applications where you just run the application in a very thin VM because it's often paired with confidentiality. So you don't trust the platform, and you don't want the platform to extract your RAM onto the content of the
Right.
memory out of the VM.
Yeah.
But here it's vice versa. You don't trust the PDF. So why do you need a VM instead of just a thin container?
I think so. The question was, why not just use containers instead of VMs? That's a fair point. Containers are contained as well to some extent, but
Like app containers specifically.
right. But the kernel is shared, right? There are many ways out of the app container. It's not as secure as VM, and that's probably why they did it this way instead of the other way. I mean, if you want to go somewhere and just go halfway, I mean, you can go all the way to better security. And I think I don't know if that's the argument you're making. I don't think so, that containers is as secure as VMs.
Absolutely not, because you don't have the emulated kernel.
Yeah, exactly.
Just on the practicality point of view.
Right. So it's not the most practical thing, but if you need just that little bit more of the security, then you have it here. If you don't, then yeah, app containers, perfect way to do it.
Is Qubes OS firmly tied to Zen, or are there any efforts to make it work on other hypervisors?
I actually haven't seen any. I think it's very tightly integrated with Zen functions and how it works. So there is, I haven't seen any efforts trying to use different hypervisor at all.
Do you think it's reasonable to virtualize Qubes OS on top of other hypervisors, like using whatever you have, KVM or below the Qubes OS layer, and then stand on top of nesting the virtualization?
Right. So you'd have like a bare metal virtualized Zen, and on top of that KVM. I don't
Maybe
know.
I have another hypervisor, and I want to virtualize Qubes OS on top of that, like using whatever I have already. Have you tried that?
Never tried it. I don't know if it would work or not. I don't think so. I mean, just based on what Zen does. I mean, there are Zen experts in the room that can say, they can tell you. I'm not sure if it's possible. Yeah. There's certainly a lot of things that containers bring to the table. when it comes to security and Qubes OS. Maybe there is something to be gained. I don't know, haven't tried it myself. I want to learn more about bootc now here, so don't know much about it, so I can't tell, sorry. So again, the question was whether bootc is something that can be integrated within Qubes OS, and if there's any benefits of doing so.
One more question. How do you handle the competition between different application VMs over physical memory? If you have a limited amount of physical memory and VM number one wants as much as possible and another VM runs another application that also wants as much as possible.
Right. I'm sure that is an excellent question, but it's a question for someone working on Zen hypervisor. I don't know how it works there. There's some ballooning, I know, right? And how it works when you don't have enough memory. No idea. I don't know.
Is it
Can't tell you.
allocated in the beginning?
I don't actually know. I don't think so, right? If you're asking me whether it's pre-allocated once you start it up, then no, right? The memory it's maxed out, right? But it's not pre-allocated. There's a minimum amount that it starts with, and then it can balloon to whatever you set it up. So it can change, right? But how it works in case there is no more memory to balloon into, to increase, I don't really know.
It can grow to that maximum amount, but it won't shrink after that. So you would have to close one of the apps.
Okay. Yeah. Sure. Any other questions? Okay. Thank you very much. Thank you for your attention.